Human eye and colourful world. Introduction. Eyes are a part of the sensory system in an organism. An organism is able to view objects, identify, absorb, and process visual details and respond to light. While 96% of animal species possess a complex optical system, many simple microorganisms detect only light, or its absence, which is characterized by darkness in their surroundings. Complex optical systems can distinguish shapes, colors, and maximize the available view. The eye is a complex optical system. Eyes detect light and convert it into electrochemical impulses in the neurons. Then these signals are passed to the brain to process the signal into an image. In this lesson, we shall learn about the human eye and its defects and how the optical system works. Objectives. In this chapter, we shall learn about the following concepts. 1. Human eye, which includes power of accommodation. 2. Defects of vision and their correction, under which we have A. Myopia, B. Hypermetropia, C. Presbyopia. 3. Refraction of light through a prism. 4. Dispersion of white light by a glass prism. 5. Atmospheric refraction. 6. Scattering of light, which includes A. Tyndall effect, B. Color of the sky, C. Color of the sun at sunrise and sunset. Let us begin our session by discussing the functioning of the human eye. The human eye is an important sensory organ as it enables us to see the world around us. Human eyes react to light and pressure, view objects in color, see three-dimensional images, see objects in motion, and recollect images from visual memory. Thus, of all the sense organs, the human eye is the most significant one as it enables us to see the beautiful, colorful world around us. So, how do we see things? Well, light enters the eye through a thin membrane called the cornea. The cornea forms the transparent bulge on the front surface of the eyeball. The eyeball is approximately spherical in shape with a diameter of about 2.3 centimeters. Most of the refraction of light rays entering the eye occurs at the outer surface of the cornea. The crystalline lens provides the finer adjustment of the focal length that is required to focus on objects at different distances on the retina. The lens system forms an image on a light-sensitive screen called the retina. The iris is a dark muscular diaphragm that controls the size of the pupil. The pupil regulates and controls the amount of light entering the eye. The eye lens forms an inverted real image of the object on the retina. The retina is a delicate membrane having an enormous number of light-sensitive cells. The light-sensitive cells get activated upon illumination and generate electrical signals. These signals are sent to the brain via the optic nerve. The brain interprets these signals and processes the information so that we perceive objects as they are. So, how does visual impairment occur? Well, damage to or malfunction of any part of the visual system can lead to significant loss of visual functioning. For example, if any of the structures involved in the transmission of light, like the cornea, pupil, eye lens, or those responsible for conversion of light to electrical impulse, like the retina or even the optic nerve that transmits these impulses to the brain, is damaged, it will result in visual impairment. Let us now check our understanding. Question 1. The change in the focal length of human eye is caused due to Option A. Ciliary muscles. Option B. pupil, option C. Cornea, option D. Iris. The correct answer is option B. Pupil. Question 2. The image formed by retina of a human eye is option A. Real and inverted, option B. Virtual and erect, option C. Virtual and inverted, option D. Real and erect. The correct answer is option A. Real and inverted. Question 3. The amount of light entering the human eye is controlled by option A. Ciliary muscles, option B. Iris, option C. Cornea, option D. Pupil. The correct answer is option D. Pupil. We shall now see what power of accommodation is. So, what is accommodation? Well, the ability of the eye lens to adjust its focal length is called accommodation. The eye lens is composed of a fibrous, jelly-like material. Its curvature can be modified to some extent by the ciliary muscles. The change in the curvature of the eye lens can thus change its focal length. When the muscles are relaxed, the lens becomes thin. Thus, its focal length increases. This enables us to see distant objects clearly. When we are looking at objects closer to the eye, the ciliary muscles contract. This increases the curvature of the eye lens. The eye lens then becomes thicker. Consequently, the focal length of the eye lens decreases. This enables us to see nearby objects clearly. This ability of the eye lens to adjust its focal length is called accommodation. However, the focal length of the eye lens cannot be decreased below a certain minimum limit. For example, if we try to read a printed page by holding it very close to our eyes, we will see a blurred image and feel strain in the eye. Therefore, the minimum distance at which objects can be seen most distinctly without strain is called the least distance of distinct vision. It is also called the near point of the eye. For a young adult with normal vision, the near point is about 25 centimeters. The farthest point up to which the eye can see objects clearly is called the far point of the eye. It is infinity for a normal eye. Hence, a normal eye can see objects clearly that are between 25 centimeters and infinity. What will happen to the lens of people at old age? Well, sometimes the crystalline lens of people at old age becomes milky and cloudy. This condition is called cataract. This causes partial or complete loss of vision. It is possible to restore vision through a cataract surgery. Now, have you ever thought about why we have two eyes for vision and not just one? Well, there are several advantages of having two eyes instead of one. It gives a wider field of view. A human being has a horizontal field of view of about 150 degrees with one eye and of about 180 degrees with two eyes. Some prey animals have their two eyes positioned on opposite sides of their heads to give the widest possible field of view. But our two eyes are positioned on the front of our heads, and it thus reduces our field of view in favor of what is called stereopsis. Shut one eye and the world looks flat or two-dimensional. Keep both eyes open and the world takes on the third dimension of depth. Because our eyes are separated by a few centimeters, each eye sees a slightly different image. Our brain combines the two images into one, using the extra information to tell us how close or far away things are. Let us now check our understanding. Question 1. The term accommodation, as applied to the eye, refers to its ability to: Option A. Control the light intensity falling on the retina. Option B. Erect the inverted image formed on the retina. Option C. Vary the focal length of the lens. Option D. Vary the distance between the lens and retina. The correct answer is option C. Vary the focal length of the lens. Question 2. The least distance of distinct vision for a young adult with normal vision is: Option A. 25 meters. Option B. 20 meters. Option C. 20 centimeters. Option D. 25 centimeters. The correct answer is option D. 25 centimeters. Question 3. Far point of a normal eye is situated at: Option A. 25 centimeters. Option B. Infinity. Option C. 50 centimeters. Option D. 400 centimeters. The correct answer is option B. Infinity. We shall now discuss defects of vision and their correction. In some individuals, the eye may gradually lose its power of accommodation. In such conditions, the person cannot see the objects distinctly and comfortably. The vision becomes blurred due to the refractive defects of the eye. There are mainly 3 common refractive defects of vision. These are: 1. Myopia or nearsightedness, 2. Hypermetropia or farsightedness, and 3. Presbyopia. We shall now discuss them individually. Firstly, myopia. Myopia is also known as nearsightedness. A person with myopia can see nearby objects clearly but cannot see distant objects distinctly. A person with this defect has the far point nearer than infinity. Such a person may see clearly up to a distance of a few meters. In a myopic eye, the image of a distant object is formed in front of the retina and not on the retina itself. This defect may arise due to: 1. Excessive curvature of the eye lens, or 2. Elongation of the eyeball. So how can we correct this defect? Well, myopia can be corrected by using a concave lens of suitable power. A concave lens of suitable power will bring the image back onto the retina and thus the defect can be corrected. Next is hypermetropia. Hypermetropia is also known as farsightedness. A person with hypermetropia can see distant objects clearly but cannot see nearby objects distinctly. The near point for the person is farther away from the normal near point. Such a person has to keep a reading material much beyond 25 centimeters from the eye for comfortable reading. This is because the light rays from a close-by object is focused at a point behind the retina. This defect arises when the focal length of the eye lens is too long or the eyeball has become too small. So how can we correct this defect? Well, this defect can be corrected by using a convex lens of appropriate power. Eyeglasses with converging lenses provide the additional focusing power required for forming the image on the retina, and thus the defect can be corrected. Next is presbyopia. The power of accommodation of the eye usually decreases with aging. For most people, the near point gradually recedes away. They find it difficult to see nearby objects comfortably and distinctly without corrective eyeglasses. This defect is called presbyopia. It arises due to the gradual weakening of the ciliary muscles and diminishing flexibility of the eye lens. What is done for a person suffering from both myopia, and hypermetropia. Well, some individuals may suffer from both myopia and hypermetropia. Such people often require bifocal lenses. A common type of bifocal lens consists of both concave and convex lenses. The upper portion consists of a concave lens. It facilitates distant vision. The lower part is a convex lens. It facilitates near vision. These days, it is possible to correct the refractive defects with contact lenses or through surgical interventions. Are you aware of eye donation? Well, our eyes can live even after our death. This is possible when we donate our eyes. By donating our eyes after we die, we can light the life of a blind person. So what do we have to keep in mind when eyes have to be donated? Eye donors can belong to any age group or sex. People who use spectacles or those operated for cataract can still donate the eyes. People who are diabetic, have hypertension, asthma patients, and those without communicable diseases can also donate eyes. Eyes must be removed within 4 to 6 hours after death. Eye removal takes only 10 to 15 minutes. It is a simple process and does not lead to any disfigurement. Let us now check our understanding. Question 1. A person cannot see the distant objects clearly, though he can see the nearby objects clearly. He is suffering from the defect of vision called Option A. Cataract. Option B. Hypermetropia. Option C. Myopia. Option D. Presbyopia. The correct answer is option C. Myopia. Question 2. Hypermetropia is rectified by using Option A. Convex lens. Option B. Concave lens. Option C. Cylindrical lens. Option D. Progressive lens. The correct answer is option A. Convex lens.